did. I'm walking around with a smile on my face today. I'm pretty excited about that. They don't necessarily have to, so I'm intentionally making them different sizes. So if I wanted to find the area of the curve from A to B, we know now that you just add up all the rectangles, and so we go, it's the summation of, let's say, this height, I'll call that C1, this C2, this C3, this C4, and so on. So we're basically, and this height would be f of C1, this would be, the height would be f of C2, and so on. So each individual rectangle is just your change in x, like that's how far apart dx is, from here to here is your change in x, or delta x, and the height is f of c sub 1, so we could say f of c sub k
N. Why wouldn't you do N?
n.
There you go. Okay.
So that's the height of the first rectangle. The width of it would be delta x sub n.
Delta means change, so he's just like saying I could change.
And we're going
Just
from
the
n
distance-
equal to
just
1
the width
to
of the rectangle.
infinity, we'll say. Okay, so all that is the sigma notation for adding up all the rectangles. And if there's an infinite amount, we have infinite amount of little bases and heights, we could find the limit, I guess, as the number goes to infinity, and it becomes the integral from a to b of your function, and that'll get you the height. The width will be dx, your change in x. A little bit different notation. Okay, so that's called an integral. And we are finding the area under the curve, just like we were before, but there's way better ways of doing it than RAM and LRAM, NRAM, stuff like that. Okay, so the dx here in integration basically is telling you what you're integrating with respect to. But if we think back to what we just did here, your dx is actually represent your change in x all along. We'll talk more about that later. Okay, so if you integrate x plus 2 from 0 to 3, we are finding the area under the curve, or between the curve and the x-axis, of the line y equals x plus 2, and we're going from 0 to 3. So, just x plus 2 looks like this line, and we're finding this area, because it's between 0 and 3, 0 and 3, so we're finding that area. Okay, so we understand what we're doing? So integral of x plus 2 from 0 to 3 is the area between the line and the x-axis between 0 and 3. That's your A and that's your B. Okay, so do we have a way mathematically to figure out that area?
Not yet.
We actually do.
Yes.
Dumb down your brains, go back a few years. Can we find the area of that area of that shape?
Make it a triangle and a square.
Okay, you could make a triangle and a rectangle, or what kind of shape is this?
Trapezoid.
It's a trapezoid, so there is a formula for the area of a trapezoid. Either way would work.
Like square and
Have you
triangle.
been here the whole hour? I was gonna say, I marked you absent.
You can look at the video.
Yeah. Video review. She was in fact gone. Okay, so area of a trapezoid is 1/2 base 1 plus base 2 times the height. This is a base, that's a base, so it's 1/2 first base is 2 plus this height. What is this ordered pair right there?
Something, or 3, no, 3,
3, 5, right? You plug 3 in here, that's 3. 3 in here, you get 5. So that means this height is 5, right? And then the height of a trapezoid is the distance from one base to the other, so that's 3. So what, 21/2? 10.5? So our answer would be 21/2 units squared. Okay? Questions?
You didn't do anything with the dx.
No, so that's, the dx, you really don't use it all when you're evaluating integrals. Okay?
Abby's wondering if they need unit square on the quiz.
Oh, on the homework quiz this one.
Yep.
Okay.
Ooh, so do I get a point for that?
So
It's the same reason why when we did our RAM program, we didn't incorporate the height of all the individual rectangles. Like here, we don't have to worry about the dx. All you have to do is worry about that expression. It'll tell you what you're integrating with respect to, and it does take into account individual, but you can kind of move it out of your head.
Can you show us how to do summation again?
Like this?
Yeah.
Yeah. And this is not on the AP exam. They will not give you summation notation like, I think I even skipped those problems in the book. Because all you're doing is changing this to f of x, and that to dx, and this to an integral from a to b.
Oh,
Did I assign those? I didn't get a
okay.
chance.
How long is this?
Okay, so what's the downfall, what's the limitations to what we just figured out? Hey,
We got a curve.
now we can find the area under all curves. What's the problem with that?
We don't have geometry for curves.
Right, we got really lucky and it happened to be a trapezoid. It might be like, if I integrate the square root of 16 minus x squared dx from, I'll say from 0 to 4.
Okay, good luck.
Yeah, we have to
Okay,
do those in our.
we can do that. Because I know what shape that is.
It's
What
a
is it?
circle.
Half circle.
It's a semicircle, right? And specifically,
Top.
this has a radius of 4, but we're only interested in how much of it,
The right.
It's a
from
it's a
0 to 4.
it's a quinta circle. Quarter circle. Is that a word?
Quarter circle is a word, yeah.
Quarter circle. A quarter circle.
It's two different words, actually.
Quarter of a circle.
He's just trying to dig into his mathematical Vegatrix vocabulary. Okay, so how do I find the area of that? It's just pi r squared divided by 4, so that's 16 4 pi
Oh, that's tough.
units squared. So this is another example of something we could do, but you can see like it doesn't help us in the big picture, so we'll have to find a different technique. But for 5.2, you're using geometry to find the areas under the curve. Okay, if the area happens to be below the x-axis, then it is a negative area. Okay, so if I have, I don't even know if that's in this.
2 plus
Plus you.
We'll call that the line y equals x, and we're going to integrate that from -1 to 2, I'll say. Okay, so we're finding the area between the curve and the x-axis. I see curve lines are considered curves. So we're finding
Straight curve.
straight curve.
Oh, the line.
Okay, so that's the line.
What are you doing?
Trying not to embarrass myself.
too late.
Where's the water bottle when you need one? Okay, so what's our answer here?
It's the trapezoid from 1 to 2.
There's no trapezoid.
Yes, there is. Because from 0 into 1 cancel each other's out. From -1 to 1 cancel.
Okay.
each
So
other
he's
out.
saying that this area
Yes.
undoes that area. Okay, so this area right here is,
Half of
it's
one.
1/2, 1 times 1, right? So it's 1/2,
Yeah.
but it's actually negative 1/2, right?
Correct.
Because it's below the x-axis. And this one would be 2 times 2, so
I was confused.
1/2, 2 times 2, which is 2.
Yes.
So our answer would be 3/2
Oh yeah.
units squared.
If we just write u squared, we know what it means.
Yep.
Okay, so
Alright.
in the assignment it says 1 through 13 odd, and that's a bunch of those like summations.
Yeah, maybe I'll,
Cut 'em
I
out.
might not make you do those.
Keep 'em
But
and let me see.
We need to explore.
No.
So, exploration 1. Are you in the mood?
No.
I
In
don't
the
care.
mood. That's a Jess.
Proof on video that Mr. Wayne.
Page 264. I'll give you a few minutes. Why don't you partner up with those around you, see if you can get those answers.
Let's stop.
I think it's hilarious that you have to have, so you have to check the rules. Is it you?
And then you can just make a cap.
And I'll assume you know why if you get the right answer. Number 2 is 0. Number 3 is 1 is correct. Number 4 is 2 pi plus 2. Everybody get that?
Yes.
Good job.
Yep.
So,
Wilson, you want to do that one on board?
sure. Can I try to explain it to you guys?
Hey Wilson, you want your picture?
I would like, yeah, I'd actually like a graph, because,
All this with one shoot untied.
Or not that,
Okay.
distribute.
so what problem
So
is
like, it's 2 times pi, and you know that sin x times pi is 2.
Number 4.
Number 4, okay. So that
Move faster.
Yeah.
I don't know, that's how I understood it.
That's right.
Can you wait?
I didn't spend my money.
Okay, actually, and like, so when it's plus 2, you raise it up, and your distance is still pi, so it's the x for 2 times the pi added to what you already have.
Now explain it.
We already know that this is 2 because that's what it started with, and the function moved it up 2, so then you just use the area of this rectangle, which is 2 pi, and then you add this 2 pi plus 2,
How do I know the rectangle is 2 pi?
because
Area
this
of
is
the
the height,
rectangle is
and
base
that is,
Okay. I forget sometimes.
You got it this way.
Number 5. One property of integrals you don't know about, but I'll tell you now. The 2 in front of the sin x, you can pull it out, and you integrate it, and then just multiply it later, so it is just 4.
She's like so satisfied.
The force is strong with this one. Number 6 is 2. Number 7 is 0. Number 8 is
2, no?
4.
Intuition.
So sine of x over 2. Oh, we're doing that 3 cal.
Okay, I like to
I don't remember
So that's 1/2. So
We all had to relearn how that works.
doing that.
So that's our b. 2 pi over b gives you a period of 4 pi. So
Bless you.
it goes all the way to 2 pi, and it's only halfway done. So it's twice the area.
Let's go 4, 2, 5.
I can't answer it. Number 9 is
Negative 2.
0.
0.
What page is this on?
Number 10 is
Does a number 10,
Oh, no, there's a number 10.
oh,
Wait a second.
as the function gets bigger, it goes to 1/3.
It's always 0.
it's always 0. How do I know it's 0?
Because Wilson said so. Because the area is always
Who's got an answer? Angel.
Because Wilson said so.
Who else has an answer?
Cancels off.
Wait,
Because like the part to the left of the y-axis cancels out the part to the right of the y-axis.
Good. And why does it allow that to happen? What kind of function does it have to be for that to be true?
Wait, how can there be left and right of the x-axis?
Symmetric on the y-axis. Axis?
No.
Symmetric on the origin.
No, it is.
Yeah.
Symmetric around the origin.
Symmetric with the origin, which makes it what type of a function?
Symmetric on the negative at y-axis.
Not even, but thank you. Like 2 syllables. So,
One of the two, or neither.
so if I had, if this was an odd function, right? If I go forever, if I call this like negative a and this a, if I integrated it from negative a to a, what would I get for an answer?
0.
I would get 0. If I went from negative a to b, you would not get 0, but as long as this distance and this distance are the same, and it's an odd function, then you would get 0. Alright. We'll do exploration 3 does, or 2 does not have as many questions, it has 3 questions. We'll kind of do them together as a class, so we're on page 266 now?
Can you show us how to do like 1 through 5 odd?
We probably won't have to do those.
You don't have to.
So are we gonna?
You're welcome, guys.
13 or whatever?
You still have to do the other ones. 7 to 12.
I don't know. Homework is 1 through.
Okay, exploration 2.
Change your notes back. It's really fine. Why would you?
Maybe they're yours.
Okay.
This is so far down.
Here.
Alright, this is not exploration 2, but I want you to know how to do this. What's this answer? Because I was looking at number 7, I think it's a constant. So, what is the integral of 10 from 1 to 5?
40.
It's 10.
Or 40.
Just the one.
Oh.
Goes up to
Because we're finding the area under the curve of y equals 10 from 1 to 5. So we're finding that area right there. So 4 times 10 gives you
40.
Make sense? So if it's a constant, I mean you could figure it out, but it's just going to be b minus a times the constant will get you there. Okay, number 1, explain why the function is not continuous from 0 to 3.
There's a hole at 2.
Okay, hole and it is a removable discontinuity because if you factor the top and bottom, it just becomes
X plus 2. It's X plus 2.
x plus 2. It can be simplified to be x plus 2. Are you with me?
Yeah.
We're going fast, so I'm just kind of doing it all out. Number 2, use the areas to show that you get 10.5. So you would just change the stuff inside the integral to just be x plus 2, and that ironically is what we did right there.
Oh.
That's not ironic, that's coincidentally.
It is coincident, yeah. So from 0 to 3, so that all you're really doing is from 0 to 3. That's the same as from 0 to 3. So we're just finding that is really it's from 0. I made that whole thing up. That's
That's spooktastic.
10.5. My gosh, that is a quinkity.
That's a
People don't say quinkity anymore. I've heard of Modern Family.
We might fix ourselves.
Use areas. Wait, this is on video? Yep, and I had it all planned. There's your answer, people. Number 3, use the areas. How did they come up with the same equation and the same boundaries of integration? That's weird. Use areas to show. We don't have time for that. Thanks for listening today, guys. We'll see you tomorrow.